Hello dear students, welcome again to MSBTE's e-content at your doorstep. Myself, Dr. B.R. Ambade, and today we are going to learn about the course Environmental Studies. Today we have to learn unit outcome 4L, 4M and 4N, as well as we have to satisfy COD, which is apply techniques to reduce the environmental pollution. And our today's subtopic is biomedical waste. Today's agenda are biomedical waste, its generation, characteristics, impacts, and the methods of management of biomedical waste, and the content of our curriculum is municipal solid waste, biomedical waste, e-waste, its sources, generation, characteristics, effect, and methods to manage it. So these are our unit outcomes as well as our learning objectives. For L, state characteristics of solid waste. For M, state the impacts of solid waste. For N, describe incineration, RDF, and sanitary landfilling. Let us have a look at the concept map of solid waste. According to our curriculum, the solid waste has three types. First is municipal solid waste, second is biomedical waste, and third is e-waste. So let us have a look at these pictures. So it is biomedical waste. Biomedical waste is defined as the waste which is generated from healthcare facilities during diagnosis and treatment is called as biomedical waste. Now all of you can understand what is biomedical waste. Now let us see what are various healthcare facilities. So for that we have to see the sources of biomedical waste. Hospitals, clinics, path labs, blood banks, nursing homes, mortuaries, funeral services, dental clinics, and animal research. So these are the sources of biomedical waste, as well as these are the healthcare facilities where the biomedical waste is generated. So how the biomedical waste is generated? The generation of biomedical waste in India is about 1 to 2 kg per bed per day. About 484 tons of biomedical waste are generated per day in India, out of which 447 tons are treated. So this is the concept map of biomedical waste. Biomedical waste are classified basically into two parts: non-hazardous biomedical waste and hazardous biomedical waste. Non-hazardous biomedical waste are about 75 to 80%, whereas hazardous biomedical waste are about 10 to 25%. Now again, these hazardous biomedical waste are divided into two parts: infectious biomedical waste and other hazardous biomedical waste. So infectious biomedical waste are about 15 to 18%, which include sharps, non-sharps and liquid waste, and other hazardous waste are about 5 to 7%, which includes radioactive waste, discarded glass, chemical waste and ash. Now next part is composition of biomedical waste. So this picture shows compositions of biomedical waste. Biomedical waste constitutes plastic as 14.28%, textile or cloth as 19.44%, liquid waste 17.34%, paper 11.6%, glass 6.16%, sharps 1.73% and other fraction of biomedical waste as 3.45%. Now next point is impacts of biomedical waste. The biomedical waste also has two impacts. First is on public health and other is impacts on environment. So the impacts on public health are nausea and vomiting, low birth weight, airborne diseases, chemical poisoning, neurological diseases, contagious diseases, cancer and various health effects on the animals. Similarly, the impacts on environment, the groundwater contamination due to leachate generated, radioactive pollution on earth and air and water, airborne pollutants, air pollution by liberation of the gases into the atmosphere, and soil pollution by the deep burial or sanitary landfilling of biomedical waste or secured landfilling of biomedical waste. Now there are various methods for management of biomedical waste. First is secured landfilling, then incineration, then shredding, then deep burial, then autoclaving, then microwaving and then chemical treatment. So secured landfilling is similar to sanitary landfilling. Only difference is that in secured landfilling, two liners are used. Okay, two liners are used. Therefore, it is called as secured landfill because biomedical waste is most hazardous waste, and therefore, to prevent the contamination of biomedical waste into the water sources, the two liners are provided, and therefore, this landfilling is called as secured landfilling. Now we have to see other method of management of biomedical waste, that is incineration. Incineration is a process of complete combustion of solid waste under controlled environment. So in case of incineration, there is a complete combustion of the solid waste. So incinerators are designed to operate at very high temperature, and it should be more than 850 degree centigrade. It reduces the volume of waste up to 95%. This is very important advantage of the incineration. It leads to energy recovery. Heat energy can be recovered from the incineration, and at the same time there is a complete destruction of toxic waste. Due to high temperature, there is a complete destruction of the toxic waste. The byproducts are ash, heat and gases. The ash is used as filler material in plinth of the building or in construction of roads or manufacturing of bricks, as well as the heat is used to generate energy. So this is the schematic diagram of the municipal incinerator where the solid waste is completely combusted at very high temperature and the byproducts as ash, heat and gases are generated through this incineration. So next type of method of management of solid waste is refuse derived fuel, RDF. The combustible fraction of municipal solid waste is shredded into smaller parts, more uniform size particles, and then these particles are used for burning in the industry as a substitute of coal. This is called as RDF. So RDF thus produced may be burned in the boilers on site or it may be shipped to off-site boilers for energy conversion. This RDF is used in boilers, either it will be on-site or off-site for energy conversion. If the RDF is used off-site, it is usually densified into pellets and this process is called as pelletization. The calorific value of RDF pellets can be around 4000 kilocalorie per kg. The RDF is used as a substitute of coal in industries. Therefore, we are saving natural resources by using RDF through solid waste. So this is the process flow plan of the RDF. So RDF municipal solid waste is there or any type of solid waste is there. The primary crushing of solid waste, then drying, then classifying, segregation, then secondary crushing and then pelletization, and then these RDF pellets are used as a source of energy and used as a substitute of coal. It looks like this. So dear students, what we learned today: biomedical waste and its sources, generation of biomedical waste, composition of biomedical waste, methods for the management of biomedical waste. And now it is a quiz time. Let us have a quiz. These are the references which are used for the outcome of this PPT. Thank you very much. Have a nice day. Happy learning. Again we will meet for the next video. Till then, happy learning. Thank you.